series project with Rick Fontenot, Joseph Lazarus, and Puri Rudick, where we are forecasting power consumption in Morocco. We got this data set from the UC Irvine Machine Learning Repository. In our data set, we have time, temp, humidity, wind speed, and power consumption. The key takeaway is that it covers a period of 1 year at 10-minute intervals. A day is 144 intervals. So why power forecasting matters? Well, if you get it wrong and produce too much power, that is wasted supply on the grid that can't be used. If you don't produce enough, you'll have rolling blackouts. Those people in Texas in 2021, they remember rolling blackouts. So now I'm going to hand things over to Puri. He's going to walk you through the realization. Puri?
Thanks, Joe. So this is a plot of a realization for the full year. Really busy to look at. Let's zoom in for just 1 week worth of the data. As you can see, the cyclic pattern in the data set. We then plot the ACF and it showed a slowly damping, while the spectral density showed a peak, which is associated with the daily seasonality. So is this data set stationary or not? For the first condition, if we have more realization, we expect to see the peak at the same time. So it seems to fail this condition. For the condition number 2, which is a constant variance, there is no strong evidence to against this. Same as condition number 3, which is a constant autocorrelation, is appear to meet this condition. So since our data set failed to meet the condition number 1, it is non-stationary. Now, Rick gonna walk us through the model ID checks.
Thanks, Puri. Puri mentioned earlier on the spectral density plot that it was associated with a daily seasonality. So we started by differencing for that seasonality. It stationarized the data, and based on the ACF and PACF plots, the Box-Jenkins approach would indicate an AR1 process beyond the seasonal difference. The spectral density also has a dominant peak at 0, though, indicating some wandering. So next, we looked at differencing to address that wandering behavior. The PACF and ACF suggest a mixed model at this point. So we'll use AIC and BIC to determine the candidates instead of Box-Jenkins. Our first 2 candidate models were chosen prior to any differencing with seasonality and chosen by the lowest AIC. Our second 2 candidate models took into account the insights we had on daily seasonality of 144. We picked the one with the lowest AIC, but also included the one we identified with the Box-Jenkins approach. The last 2 models include that differencing term and were picked the best BIC and AIC. So now let's see how these models did. Kind of as expected without that seasonal term, our first models just regress to the mean and don't look like very good forecasts, but set a baseline for us. Now let's see how the seasonal model performed. You can see the red forecast line matches almost perfectly on a 1-day forecast. When you look at a 1 week and a 1 month forecast, they again perform well, with one area for improvement being the peak consumption every day tends to vary, and our model is not following that variation in the peaks. Let's see if the model with differencing can help. Again, the model looks to be performing pretty well. You can see the forecast on the 1 week and 1 month now have some movement. It's not just constant, but it is not following the variation of the realization. It's trending downward back and kind of regressing towards the mean. So the next slide, let's look at a comparison performance for all of our candidate models. We looked at the error terms for 1-day, 7-day, and 30-day forecast, as well as a rolling window that averages out the error for every day within the year. The seasonal models without differencing performed the best. And within those 2 seasonal models, our preferred model, the one that performed the best for us, was the one identified by the Box-Jenkins approach with the AR1 term. Now Joe's going to talk about our next steps.
Thanks, Rick. Wow, that was a lot. And we're excited to show you what we're going to bring in the future, which is going to be some multivariate analysis using the VAR method and neural networks. With those multivariate analysis, hopefully we can predict those higher peaks. Will it be temperature? Will it be humidity? You have to stay tuned to find out.